So welcome back. So in the first video we were looking at the difference between class limit, class interval and the class boundary. So in this video I'm going to show you how to plot a histogram for a uniform class interval data and a non-uniform class interval data. So let's begin. So you have the two types of data down here. So consider the following data. So we have the first one, as you can see. Then we have the second data, as you can see. So finding the class interval for the first data, I said in my first video, I said that class interval is given by upper boundary minus lower boundary. So the first class interval here, we're going to have upper boundary of 14 is 14.5. This is 9.5. So 14.5 minus 9.5, you're going to get 5. Here also 5. Here also 5. Here also 5. So if you look at this data here, you will realize that the class interval is the same. So the class interval is uniform. So meaning these are uniform data. So when plotting a histogram for a data whose class interval is uniform, we plot frequency against the upper class boundary. So frequency against the upper class boundary. So for a data whose class interval is uniform. So you can write that when plotting a histogram for a uniform class interval, comma, plot frequency, that is on the y-axis, frequency against upper class boundary. This one x axis. So that's what we have. So if you come to the second data, if you look at the class interval here, so the class interval here in the first data, we are having this is 5. Then this one here for the second table we have 10. It's the class interval. Then this one is 5 again. Then this is 15. So that's the class interval. So upper boundary minus lower boundary, you get class interval across. So if you look at the class intervals, they are not the same. Here we have 5, here we have 10, here we have 5, here we have 15. So the class interval is not uniform. So this one here, you need to calculate frequency density, because here you cannot plot frequency against the upper class boundary. Instead, you are going to plot frequency density against the upper class boundary. So you need to calculate frequency density. So frequency density is given by frequency over class interval. Frequency over class interval. So that's how we get frequency. So in the first box here, we have the frequency, which is frequency over class interval. So we have frequency, that is 6 over class interval. So the class interval is 5. So this one is giving us 1.2. It is giving us 1.2. Then next we have frequency, which is 24 divided by the class interval, which is 10. This is giving us 2.4. Then next we have here, that is 20 over class interval, that is giving us 4. Then lastly we have frequency is 18 divided by 15. So 18 divided by 15, this is giving us 1.2. So that is what we have. Then from there you look at the class boundary. So we are plotting frequency. We are plotting frequency density. This one will be on the y-axis, frequency density on the y-axis against the upper class boundary. So I said upper class boundaries is given by adding 0.5 here. So you are going to add 0.5 here, add 0.5 here, add 0.5 here, add 0.5 here. So upper class boundary here is 14.5, adding 0.5. Here we have 24.5. Then here we have 29.5. Then here we have 44.5. So that is the second thing which you have to calculate when plotting a histogram for a data whose class interval is not uniform. So you need to calculate frequency density for a data whose class interval is not uniform. So thank you. In my next video I'm going to show you this on a graph paper. So please, you are welcome. Thank you.